Good morning, everyone. So today we're going to be doing day 2 on annuities. Your homework for tonight is going to be to do problems 1 through 7 odd on the day 2 worksheet, as well as numbers 8 and 9. So that's 1 through 7 odd, as well as 8 and 9 on that day 2 worksheet. So before we begin, I want to just recap what we did last time, which was our intro lesson to ordinary annuities. And again, ordinary annuities are ones where you have a regular periodic payment that is made in the future. Now, we talked about retirement accounts such as an IRA, a 401k, and a 403b. Now, all of these are ones where you are adding money to your account. So you're adding money to the account on top of your payments, your periodic payments. Well, today we're going to be looking at loans and mortgages. Now, loans and mortgages, you start with the highest amount that you owe and you actually pay off. So you are actually going to be paying off the money owed until you get to the very end where you don't owe anything, where you owe zero. So in order for this to happen, you are actually going to be subtracting our annuity equation. So it's going to be subtracting in there. So let's start with that. So loans and mortgages are going to be what we look at today. A loan payment to a bank is going to be a regular periodic payment characteristic of an annuity. Your present value of the annuity is A, and that's going to be the amount borrowed. So that's the amount you are starting with. And then R is going to represent the monthly payments that you are making to that account. So again, since you are paying off the amount. So you are going to be subtracting in our equation to make it so that the amount you owe becomes less and less and less. Whereas in a 401k, the money that you are putting in is getting larger. You're adding. So present value of an ordinary annuity when you are paying off is going to be in the format of RA equals R times 1 minus 1 plus R over N, and this is a little different, it's going to be to the negative NT. Again, all over that fraction of R over N. Close it up. Where R is your monthly payments, big R, the capital R is, and then little r is going to be your interest rate. N is the number of periods in the year that you're looking at. T is number of years. So again, you are now subtracting the annuity equation, and you're going to be having a negative as your exponent. But that does not mean that your amount becomes negative, because a negative exponent is really just 1 over this quantity. So to the negative nt is really 1 over the quantity 1 plus r over n to the nt. All right, so let's begin. The first example we are looking at is going to be the purchase of a house for $250,000. So that is how much you are starting by owing. So that is what you are starting with, and that is A. And we are going to be paying monthly payments. So that's N equals 12. And the mortgage is for 30 years. So for the payment to last 30 years, that's T equals 30. And our APR, that's our interest rate, yearly interest rate is 5%. So lowercase r is 0.05. And again, our formula is A equals R times 1 minus 1 plus r over n to the negative nt all over r over n. Okay. Now, and R is going to be our monthly payments. So that is our goal here. We're going to figure out what our monthly payment is going to be. So that's R. So we are solving or finding R. Total amount that we borrow, 250,000 equals R times 1 minus 1 plus 0.05 over 12 to the negative 12 times t is 30 over 0.05 over 12. And then once we figure out what this is, we're going to have to divide 250,000 by this amount to get what R is. So I'm going to do this on my calculator. Do it on my computer here. Okay. In our fraction, we have 1 minus parenthesis 1 plus 0.05 divided by 12 and that's being raised to the negative 12 times 30. And then we are dividing by that fraction of r over n, so 0.05 divided by 12. Now again, that is just giving us what r is being multiplied to. Okay. So now $250,000 equals r times that quantity of 186.281617, which I'm sure keeps going. And now I'm going to divide both sides by that 186 the decimal. And on your calculator, you can just do 250,000 divided by, and then hit second answer. So you use the previous answer that you got there. So that leaves our monthly payments to be $1,342.05. So that's our monthly payment. Well, if this is our monthly payment, what does that total after 30 years? Okay, well, so we start with $1,342.05. That's monthly, so multiply that by 12 months, which would give you 1 year times 30 years. And I already did that in my calculator, so I'm just going to write it down for you. That's going to be $483,138. So after 30 years, you paid $483,138. But how much was our house purchased for? Well, it was purchased for $250,000. So that means how much interest have we paid? So $483,138 minus $250,000 is going to give us our interest total of $250,000. $33,138. So you have paid almost as much in interest as you have for the house. Okay, so now what if we decide that, well, that's not really a good option for us. We don't want to be doubling what we pay for our house. So what if we pay a little bit extra every month? What would that do to our mortgage? How much would we save in the long run? So instead of that payment of $1,342.05, what if we now upped that payment? So we have the same mortgage, but we're upping our payment to $1,600, which really isn't that much of a difference. It's just $258 about, right? So if we were to add an extra $258 to our mortgage payment every month, what would that do? How long would it take for us to now pay off our mortgage? So this is R, and everything else stays the same. We still had that $250,000 mortgage that we initiated, but this time we're trying to find what T is. We're trying to see how long that's going to take. So that equals our initial payment of $1,600, not 16,000, times 1 minus 1 plus 0.05 over 12 to the negative 12 times t divided by 0.05 over 12. All right, so now that we have the setup of our equation, we're going to want to solve for the exponent t. So the first thing I want to do is I want to figure out, well, what is this 1600 divided by that 0.05 over 12? And when I do that, I get 384,000. So this divided by this ends up being 384,000. So if I were to divide by 384,000 on both sides, I would end up with the decimal of 0.651, and it keeps going a little bit, equals 1 minus 1 plus 0.05 over 12 to the negative 12t. And then I want to still isolate that exponent, so I'm going to subtract 1 from both sides. And then the last thing is going to be to divide by negative 1 to get rid of that negative out in front. So whatever I get there, minus 1, and then divide by negative 1 gets us positive 0.348958, it keeps going, equals 1 plus 0.05 over 12 to the negative 12t. And now that I have my exponent term isolated, I can go ahead and do ln, or regular natural log or regular log on both sides. I'm just going to do ln. So I have ln of 0.348958, and just save that on your calculator so you can hit the button to reuse it, equals, and don't forget to bring that exponent out in front now, negative 12t ln of 1 plus 0.05 over 12. And you're more than welcome to simplify what that comes to if you'd like, but it's a little easier for the point of the lesson to leave it for now. And now here is t. I want to isolate it, so I want to get rid of that negative 12 being multiplied, as well as the ln of that quantity being multiplied. So I'm going to divide by 12 ln of 1 point plus 0.05 over 12, divided by negative 12 ln of 1 plus 0.05 divided by 12. So now in my calculator, I'm just going to figure out what that division is. So put it in as a fraction would be easier. ln of 0.34. Well, I'm actually going to just delete that. Just going to reuse the number I had gotten from before. So ln of that divided by -12 ln 1 plus 0.05 divided by 12. And I get 21.099 to 21.1 years. So again, the trick to make this go a little quicker is to figure out what is that first and then divide by it, and then subtract the 1, divide by the negative, and then do log of both sides or ln of both sides. All right. And now the last thing that we want to figure out is how much interest will you have paid over the course of the loan? Well, to figure out how much interest we have paid, what we have to do is take that mortgage payment and multiply it by the 21 years. So that mortgage payment was $1,600 every month, so that's 12 months times the 21.1 years. And that will show us how much we've paid in total. So in total, that comes out to $405,120 is what we've paid. But of that $405,120, the mortgage was initially $250,000. So if we were to subtract those, you would see how much of it went to interest. So when you subtract that, you end up with $155,120 in interest. So by paying that little bit extra every month, we have now cut our interest down to $155,000 as opposed to before, which was $233,000. So it saves you quite a bit of money. All right. Let me know if you have any questions. Please see me in office hours or email me. Good luck. Take care.